Okay, problem two. This is Luke and Vader having a lightsaber duel in Cloud City. Luke falls in this carbon freezing pit, and there's all these cryogenic gases hissing around him, going like that. So he's about to get frozen because Vader wants to freeze him and take him to the Emperor. This here, in case you couldn't tell, is my stick figure Darth Vader, with the cape, and here's the lightsaber and all. And so Luke's only hope here is he's got to jump straight upwards. There are these cables hanging 5 meters above his hands, and he's got to just jump up. So what we said the problem was, thanks to his Jedi training, he's going to start at position 1 and try to end at 2. Thanks to his Jedi training, he can jump up at an initial upward speed of 10 meters per second. So at 1, we've got a kinetic energy of 1 half mv squared, and that's his initial velocity, which is that his initial speed, that 10 meters per second. And the other thing we need to do there is kinetic energy due to gravity. This is effectively it's a projectile motion problem we're doing with energy. So we need to define where potential energy for gravity is 0. I'm just going to arbitrarily say it is when Luke is on the ground. Okay, so 0. Great. Now he jumps up, and does he grab the cables or not? What we can do is we can say kinetic energy here is going to be 1 half mv2 squared. So I should really call this v1. That's what we were given. So I'm just going to keep it neat. v2 squared. And, really we can just say this is kinetic energy 2, kinetic energy 1. And here ug is mgh. So the question is, if you take his Emech at each, 1 half m v2 squared plus mgh, and here Emech is 1 half m v1 squared. Okay, so the question is, does he have enough kinetic energy or enough total energy here to reach this state? And so what we're going to do here is we're going to set these equal and see if that gives us workable answers or not. So 1 half mv2 squared, that's the speed he still has left when he gets to the top, if any, plus mgh. Okay, so let's see. We want to solve, really what we want to do is solve for this v2 here, right? We know all the rest of them. We know Luke's mass. Actually, we don't know Luke's mass. Well, you could use it from the previous problem, but it doesn't matter because it's going to cancel out. You know g, you know the height he has to jump, you know his initial speed. So we really want to solve for this v2 here and see if it's even possible, if we can get a sensible answer for that. So let's see. I think if we reorder this a little bit, first of all, we can multiply everything by 2 and divide everything by m. So we get v1 squared equals v2 squared, that's this term coming down, that term, okay, plus 2gh. And then what you'll get is v2 squared equals v1 squared. I'm just moving the 2gh around, minus 2gh. I'm flipping the sides, okay? So the question now is, we take this here and we say, well, is this going to be a positive number? If this is a positive number, then indeed Luke does have some speed left when he gets up there. If this is a negative number, then what it means is that then v2, Luke's speed at the top, would have to be imaginary. And that's, that's how physics tells us that it can't happen. So we need to see if this is positive or negative. So if we plug in, the numbers we know, then v1 squared is 10. So that's 10 squared, which is 100, minus 2. And this is where your choice of little g actually matters. I'm going to use 10 for little g. That's what I like to do. And the height is 5 meters. And so you take this side as 100, and this is 2 times 10 is 20, times 5 is also 100. So in my case, when you take g equal to 10 meters per second squared, what you get is that v2 squared equals 0, which means his speed when he gets to the top is 0. So he just barely makes it. If you use 9.8 for g, then this side is going to turn out to be 98. So he'll actually have a little tiny bit of speed left. He'll have like 1.4 meters per second. Well, Is that right? Yeah. He'll have 1.4 meters per second left when he gets there. So, either way, he makes it. It's to his advantage if the Cloud City people are using 9.8 for G. I mean, they've got artificial gravity probably, right? So you figure if they're using a slightly lower G, that probably helps Luke out because he doesn't have to worry as much about sort of stretching his fingers to the max as he would if it was 10.